condition, this ratio value will be so close. And that is what we mean, or we are describing it as the ratio being equal to a constant. So sine of I on sine of R is equal to a constant. This value of the ratio must be constant. Please, are we okay? So we have practical work in the lab to test Snell's law. Okay. Experiment to measure the refractive, or to prove Snell's law or measure the refractive index. And this constant value of the ratio is what we call as the refractive index, of the material. And what is the refractive index of a material? Every optical material, or material that allows light to go through, has its own value of refractive index. And the refractive index of a material explains the measure of the material's ability to deviate the path of light. Okay. What is the refractive index of a material? It is the measure of the material's ability to deviate the path of light. So the refractive index of a material is the measure of the material's ability to deviate the path of light. So it measures the refractive index of a material, measures how much the material can deviate light. So if a material has a refractive index of 1.5, okay, it means the ability of the material to deviate the path of light, it's 1.5 times the ability of air to deviate light, or 1.5 more than the refractive index of air. Glass, for instance, glass has a refractive index of 1.5. It means that glass can deviate the path of light 1.5 times, okay, as the deviation that can be done by air. Is that okay? So that is what it means by the refractive index of a material. Any question? Hello.
Please, since there's a constant, does it mean that if you take for any given pair of medium, as long as they are the same, they will give you the same constant?
Yes. So long as
if you take
go ahead.
So please, if you take air and glass,
yes,
because you have different densities which are constant, they would give you maybe a constant K, which would be as another maybe another experiment of air to glass.
I don't get it. It means you've made the question wrong.
Okay, instead, I mean that if somebody is doing a practical on the refraction of light from air to glass,
Yeah.
someone else does a similar experiment, they will both get the same
They
answer.
say you need to get values the same or very, very close. It may not be the same because of experimental errors. Okay.
Mm,
But so
yes,
long
please.
as you are all using the same air to glass for your experiment, you need to arrive at the same or almost the same answers.
Yes, please. And glass to air would also be different.
Yes, glass to air would be the reciprocal of the same answer. So if the refractive index from air to glass is 1.5, then glass to air will be equal to 1 over 1.5. We will go through reversibility so you understand.
Yes, thank you.
All right, do I clean the board? So that's the explanation for Snell's law. Snell's law. Hilda, are you okay?
Yes, please.
Okay. Now let's look at, so that is it with refractive index. Refractive index of a material.
Mr. B,
Hello.
please, what was the symbol for the refractive index?
Either mu or mu n. I said looking like NV, something like that. So either this or that is a symbol for refractive index.
Yes, please.
Okay. Okay. Now let's look at how to express the refractive index of a material. The refractive index when light is from air to another medium, or if the first medium is always air, then we are talking about the absolute refractive index of a material. So n, which is in the situation where we are looking at the refractive index from Snell's law perspective, then absolute refractive index can be expressed as sine of I, the ratio of the sine of I to the sine of R. This explains the absolute refractive index. Absolute refractive index because the first medium, the light is being propagated from air to glass, to another medium. So long as the first medium is air, this refractive index is called absolute refractive index. What I mean is that supposing we have another situation. Let me be specific. If I say this time around, the light is being propagated from water to glass. Okay, water to glass. In the first situation, it is from air to glass. Water is less dense compared to the density of glass. So it means that the part will still be deviated towards the normal. But this refractive index is the refractive index of glass, refractive index of glass with respect to water, or the refractive index um of glass through water. And so if I'm expressing the refractive index, this can be expressed as mu of glass, okay? There is refractive index of glass, but through the first medium, which is water. So let me bring it here for clarity. The first medium is water. So water. The second medium is glass. So this expresses the refractive index of glass with respect to water, or glass through water, which is expressed as Wg. And because this first medium isn't air, we can describe this as absolute refractive index. Please, are we okay?
No, please.
Let me go over for the second time. Let's assume a situation where light is being propagated from air to another denser medium. So this is air, this is glass. We describe the refractive index as refractive index of the second medium, glass, with respect to the first medium, which is air. So the symbolically, this is mu air to glass. Okay, so it's the refractive index of the second medium, which is glass, through or with respect to the first medium, which is air. Now, because this first medium is air, we can describe this as simply this. Simply mu of G, refractive index of glass, absolute refractive index of glass, which is written as this, or it can also be expressed as simply mu. So when you see mu without the two media indicated, it means it is an expression of absolute refractive index, or N. So we talk about absolute refractive index when the first medium is air. Are we okay? The absolute refractive index of a material when the first medium is air. Now I'm giving another situation where light is being propagated from another medium, from water. The first medium is water. The second medium is glass. Glass is denser than water, so it will deviate towards the normal. Okay, this is I, this is R. If we are deriving an expression for the refractive index, then mu or N, okay, is equal to the first medium is water, the second medium is glass. How do we express this? This is the refractive index of glass with respect to the first medium, which is what? Water. Now, what I'm saying is that we cannot define this or express this as absolute refractive index. Why? Why can't we express this as absolute refractive index? Yes, let me pick your views. Why can't we express this as absolute refractive index?
You said yeah.
Uh-huh.
Please, is it because the first medium is not air?
Exactly. So all that I'm saying is that when you hear the absolute refractive index of a material, then the first medium through which the light is propagated must be air. If it is not air, it cannot be described as absolute refractive index. Are we
Mr.
okay?
Dia,
Hello?
yes. Mr. Dia, so please, the only significance of like the whole concept is just giving you a clue of what the first medium is.
Yes, the word or the adjective absolute describes
Okay.
the first medium, and it must be absolutely air.
Okay.
Okay. If the first medium is not air, then we are talking about relative refractive index. Relative refractive index. So relative refractive index. So this explains the relative. Hello. Oh,
Please, does the like the
your line is
makes
breaking. Kezia, Kezia,
absolute.
reposition and get reposition. Your line is breaking.
So does it still remain absolute?
Come again. Eh, Kezia, just reconnect and then ask your question. Your line is breaking, so reconnect and ask your question already. Just reconnect. Just reconnect.
I was asking if the it's okay. Please.
Kezia, you reconnect, get a clear, okay, network, and then just ask your question. Your line is even breaking my eardrum. So once this expresses the relative refractive index of glass with respect to water. Okay, so where we have water and glass, this is the refractive index of the second medium, glass, with respect to water. This is actually the refractive index of it's like relative refractive index of glass with respect to air. But because the first medium is air, we are free to call it as absolute refractive index. Kezia, Brittany, Dromo, uh, uh, and the rest of you, are you okay?
Yes, please.
Mhm.
Yes, please.
All right. All right. So now, absolute refractive index can be of a material can be expressed in different ways. One of it is the sign. So long as the incident ray is from air to a denser medium, it can be N or mu. Please, Deborah and the rest of you, the symbol is either this N light or mu. I'm fond of using this, so you will see, you most often see the symbol. So take note. So absolute refractive index of a material can be, you can apply Snell's law, sine I over sine R. Casey, are you back? The same absolute refractive index can also be expressed as speed of light in air or vacuum over the speed of light in a material. So when we compare the speed of light in air to the speed of light in another material, it also explains absolute refractive index. So we say C over V, where C is equal to speed of light in air and V is equal to the speed of light in a medium. Absolute refractive index mu can also be expressed in terms of wavelength. The wavelength of light in air or vacuum. Okay, the numerator must always be air because we are talking about absolute over wavelength in wavelength of light in a medium. Okay, so either you express it in terms of Snell's law or you express it in terms of these other ways. As I told you that velocity of light is directly proportional to the wavelength. So if the velocity of light is changing in a medium, then of course its wavelength would also change in a medium because they are directly proportional. Are we fine? Are we okay? Now,
Yes.
frequency of light does not change from one medium to another medium. Frequency of light does not change from a medium to another. The reason is that, you see, I said V is directly proportional to lambda. V is directly proportional to lambda. So V, when we introduce an equal to sign, what must be there?
Constant.
A constant. And the constant of proportionality K is the frequency. So for one medium into another, this F is the constant, so it doesn't vary. Hence, V is equal to F lambda is the formula for the velocity of wave, anything wave, being it light, sound, or whatever. This is it. So the frequency of light does not change from one medium to another. However, its speed, its wavelength changes. Are we okay? Hey, the number is dropping. Kezia, please, if you are here, ask your question. Kezia,
Mr.
uh-huh.
Please, I
Okay.
was considering my question has been answered.
Okay. Okay.
I was going to ask if like it
If
has been
what?
answered because like every material, as long as A is the initial material, it becomes an absolute
Yes. Okay. All right.
refractive index.
All right. So that's it. Now, the absolute refractive index. Absolute,
Thank you.
welcome. Absolute refractive index of a material is always greater than 1. So n or mu is always greater than 1. I want somebody to explain to me why. Dromo, the ball is in your court, or the court is in your ball. Dromo, I want you to
Yes,
explain to
yes,
us
sir.
why absolute refractive index of a material is greater than 1.
Sir, please, it could be that since the speed of light in a vacuum is very is fast, the value for the speed of light in air will always be greater than the value for the speed of light in the medium,
Mhm.
which will make the refractive index greater than 1.
Okay. Any more view? Kezia, and hey, Abigail is gone. Brittany, Ella, you are here. Deborah, Hilda, and Adra. Why do you think refractive index, absolute refractive index of a material is always greater than 1? All right, let me pick it. You see, I said absolute refractive index can be expressed as this. The last one, let me give a symbol representation for the last one. So mu is equal to wavelength in air over wavelength in a medium. Okay. So we are expressing absolute refractive index in terms of 1, 2, then 3. Looking at the first one, Snell's law. Snell's law, air, because we are talking about absolute, then medium, maybe glass, water, whatever. The deviation of the refracted ray, will it be away from the normal or towards the normal? Give me a unified answer. Will it be away or towards the normal?
Towards the normal.
So it's towards the normal. So if you have two is gone, if you ask it. If it's towards the normal, I will be greater than R, isn't it? I will be greater than R. And I is the numerator. R is the denominator. Okay, so if you have the numerator greater than the denominator, then the ratio will be greater than 1. If we look at the second one, mu, or please, it can be NO. I'm just used to mu, so understand when I use that. So mu, this is C, speed of light in air, and then speed of light in another medium. Speed of light in air is the greatest, 3 times 10 to the power 8 meter per second. And it's greater than when it enters another medium. So here too, the numerator is greater than the denominator. So the ratio will be more than 1. Then wavelength. If I said V is directly proportional to lambda. So if V is greater in air, then clearly wavelength would also be greater in air than in another medium. So this ratio is also greater than 1. Hence, absolute refractive index is always greater than 1. Understood?
No,
Mr. Dia, please.
please.
Come again.
Mr. Dia,
No, please.
Deborah, Kezia, all that I'm saying is that, you see, when you look at 3 different ways of expressing absolute refractive index, the numerator in each case is greater than the denominator. And if you have a fraction and the numerator is greater than the denominator, then the results would always be greater than 1. Okay, so if you have 10 divided by 9, the result will be 1 point something. So, because in each case the numerator is greater than the denominator, then the whole result, which represents absolute refractive index, would also be greater than 1. That's all that I'm saying. Are you okay?
Yes,
That was,
please.
okay. So that is it with absolute refractive index. Okay, so it's 450. Unfortunately, please, the number today, we have more absentees than those of you around. And so let's end it here, okay? And then continue on our usual day, okay, on Wednesday. Because I actually do not understand why a lot couldn't make it for today. Okay. So let's call it a day and continue on Wednesday. Do you agree with me? Though we've done something. So
Yes, please.
okay, so Hilda, Adelaide, Akofala, Brittany, Deborah, Dromo, Ella, Kezia, and Anadra will continue on Wednesday, right? Until then,
Okay,
Yes.
bye bye to all of you. Hmm.
Bye, Miss Peter.
Bye, Mr.
Bye,
Dia.
Mr.
Mhm.